Sir, wheel wear management, mechanical section. I think it is everybody knows, but seniors may know the things, but the juniors may not be. Okay. So anyway, we are going to, in this session, we are going with wheel wear management. So, first of all, we have to tell something regarding wheel. After that only we can go to that wear management. The basic, minimum basic features we will tell first. Wheel having this, these are the main features of the rail wheel set wheel. Then profile of the wheel, wheel wear locations, limited of wheel based on the shape concern. So many some restrictions will be there, the dimensionally clearance will be there based on this safety concern, and the financial expenditure on wheel change in midlife. This is earlier. Yeah. Okay. Okay. Wheel. Simple schematic diagram of a wheel. For not for seniors, those who are joined recently, they can simply. First of all, we'll tell about the profile of the wheel. Profile of the, if we are taking a cut portion of this portion, cut portion of this area, it will be like this only. The bottom. This is the end of the flange tip. This is the cut view of the wheel. Here having some dimensions. That standard dimensions is there. From the tip of this flange at a distance of 13 mm, the width of the flange it should be 32 mm for new wheels. 32 mm. And at a distance of 22 mm, the flange thickness should be 37.5. Another side it is there, it is not mentioned. 37.5 mm. And some radius it is already mentioned. This, some location 1, 2, 3, 5, 6 location it is there. These are the radius they have to maintain while tire training or while at the time of receiving new wheel set. Mechanically, the drawing will be there and a lot of dimensions are there. No circuit diagram. This is a total dimension, width of the wheel, 135 mm. Is working. Double touch on. Ah, ah. Width of the wheel. That also it is mentioned. It is a 133 mm. 133 mm. And 1 in 20 tapering will be there. This is tapering. The tire portion, one tapering will be there. That is a dimension will be 1 in 20 mm. 1 in 20 mm means once in 20 mm, 1 mm reduction will be there. Suppose if here it is the diameter of the wheel will be 100 mm. After 20 mm, it will reduce to 1 mm. That will be 99 mm. And another 20 mm, it will be 98 mm. Like that, tapering will be there. Here we are following two types of wheel profile. One is thick flange and another is wear adapter profile. Thick flange mainly we are using in passenger locomotive, especially now in WP4 locomotives. WP4 locomotive. What will be the profile of the thick flange template? This is here. This and all same only. Now you can see 37.5 mm like that. இந்த இது பாருங்களேன், இந்த 22 mm டெப்த்தில் வந்து இந்த டிஸ்டன்ஸில் பிளாஞ்சோட திக்னஸ் வந்து 37.5 mm இந்த மாதிரி. அதே மாதிரி இதில் வந்து 37 ஆகும், 37.5 mm தான். ரெண்டிலும் வந்து அட் டிஸ்டன்ஸ் ஆஃப் 13 mm வந்து பிளாஞ்ச் விட்த் வில் பி 32 mm. 32. அது பாயிண்ட் டெசிமல் வில் பி தர் 21 like 32 will be there. That is not need not to consider. இந்த மாதிரி வச்சுக்கணும். And main difference is here 1 in 20 tapering, where in the case of thick flange, here it is starting from the mid of the wheel, 1 in 20 tapering. Here it is from the beginning onwards it will be there, where in the case of wear adapter profile. So because of 1 in 20 tapering differing in various profile, wheel wear also it is differing. And apart from some radius, one change, such changes also will be some 13 mm, 16 mm, like this. You can see here difference in profile. Here it is 16 mm, here it is 15 mm. Where in the case of other, it is varying like that, 13, like that. There is a different radius in the root area differing in both that wear adapter profile and thick flange profile. That is the main difference. And 1 in 20 tapering starting from the mid of the data distance of 63.5 mm, 1 in 20 starting. The whereas in the case of wear adapter it is starting from beginning onwards. These are the basic drawing number CSL 300 and SKDL 2561. Wear adapter WH7 goods and all wear adapter, and more WP7 also. WP7 also now we are running with wear adapter profile only. In that only we are able to save that wheel life. Where in the case of thick flange, we are not able, we are struggling like anything. Wear adapter and the 100 wear adapter இப்போ வந்து ஸ்பீட் இன்க்ரீஸ் பண்ணியிருக்கு சார். நமக்கு இந்த வித் த ஹெல்ப் ஆஃப் டாம்பர், ஹைட்ரோலிக் டாம்பர் இன்க்ரீஸ். We can work up to 140 kmph like that it goes. Now it is our WP7 locomotive all except one locomotive. Thick flange is a WP4 we are maintaining thick flange. Since it is a flexi coil bogie, apart from that it is WP4 don't have that hydraulic damping facility. It will oscillate like anything. There is a thick flange. Here it is that wheel can go from here to like this, it can oscillate. But where in the case of thick flange, it is restricted from here. So jolting will be more. So that way we are compensating through that hydraulic damper only. Your wheel life is more. Main wheel life. WH7 and WP7 we are running with the wear adapter. And here I told that flange thickness at a distance of 30 mm, 20 mm, this much, 32 and 37.5 it is there now. This and all new wheel or turned wheel turned after completion. Where in the case of condom, profile become condom. When it will become condom, this area, this much wear will take place. So new means like this it will go. And where in the case of condom profile, it will bend. That prior end material will bend. That profile and there will change like this. This one is a new profile. This one is a condom profile. This much wear will take place. That much wear will take place longitudinal, lateral, that movement will be more, jolting will be more. That and all against the safe working of the train, locomotive. That's why as a safety concern only they are restricted to that it will come. That flange where it is 3 mm like that it will come. Okay. This is a difference between the radius. Where in the case of the thick flange, where now normally where now we are discussing about this wheel wear now. So where normally where will take place? Where will take place on these portions? That's on the tread portion. Tread portion means this one, this area, this area, this area. Okay, and root radius. Root radius means you can see this portion, this angle. Root radius nalla. I already told now. Root radius, this portion, root radius. And next one is a flange portion. Flange portion means this area. Flange width which will get reduced on this due to that riding on wheel, rubbing with wheel, rail, rubbing with rail. Okay. The symbol. This is a tread portion. Tread portion means this much area is a tread only. This much area is tread only. This is a root area. This is a flange portion. Normally, where will take place is a tread portion and root radius and flange area, where it will rubbing with the rail. Hmm. Ah, all wheel portion. Periphery. Periphery. Okay. Then okay. The limits of wheel wear based on safety concerns. First of all, diameter. How much it should be? New one, this much. That is, new one should be 1092. Earlier one plus side one relaxation was there. 1092 plus 5 that was there. And contamination is limited to 1016 mm. 1016 mm. Once RDS has given minor relaxation, one time only since scarcity of a wheel disc. At that time it was 1012. Now it is revised. Now it is 1090 to 1016 only. See, this is the new diameter and this is the condemned diameter. What will be the effective diameter of the wheel? 76 mm. In that 76 mm wheel dia only we are using for the entire life of the disc. Here are some limits of wheel wear based on safety concern. Apart from that wheel wear, okay, we can reduce the wheel wear. Apart from that, some safety concern also it is there. There should not be any accident. So in that aspect also we have to keep the limit of the wheel, some particular level. So these are the things. In a wheel set, there will be two disc wheel na. This two disc will be there. Wheel will be there. If the x this side is diameter is x means here it also should be x. In that some tolerance it is there. Only 2.5 mm maximum it can plus 2.5 mm like that limit is there. And once turned out new means new while receiving new wheel set or turned wheel set means the difference in the same axle should be 0.5 mm. But during service it can go up to 2.5 mm. That also will vary. That also will vary according to type of the locomotive. Where in the case of WAP 7 it will vary. Like that, the same bogie also having some restriction. Wheel restriction is there. That it should be maximum of 4 mm and minimum of 2 mm. While receiving new wheel set or turned wheel set, it should be 2 mm. During service, it can allow up to 4 mm. Suppose here it is 1050 wheel. 1050 wheel means how much it can go in the same bogie? Same bogie. So here it is a maximum 4 mm only, 1054. Axle 1 will be 1050 means axle, how much dia we can provide in as a axle 2? 1054 only. Okay. But even if it is giving for wheel turning, then how much they have to keep? 1052 only they have to keep. All these are based on the traction motor designed for taking this even load now. Even though some relaxation is there, plus or minus it is there, the locomotive itself is designed for taking the same load only, all axles. Some relaxation is there, plus or minus will be there. So, for that also it is helping. Otherwise, one axle will take more load, another axle will take it. It should be compensated in the dia difference. And like that, same bogie also. Same bogie, 15 mm after turning. But it can go up to 20 mm during service. That also, Sandeep, why you are sitting? Ingiva, Ingiva. 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 Why you are there? Secret order. Okay. This and all, this will be common, but where in the case of WAP, this one for WAP7, where in the case of WAP4 and WA7, here it will be 5 mm and here it will be 25 mm maximum. Huh? Okay. Same loco means one bogie having wheel dia, minimum wheel dia of 1050. Another bogie, how much it can go up to? It can go up to 1020. 20 mm maximum difference it is there. And where in the case of WA4 and WAP G7 it go up to 1075. Like that. Minus side also it can go. If it is a 10, bogie it is 1050. Bogie on how much it can? Same. Plus or minus for the yeah. This is we can put even 1030. Like that. Okay? Okay. ஒரு ஸ்லைடுக்கு 1 மினிட் தான் முடியும் சார் dia will measure on the center portion, sir. This is total is 63.5. The center will be 63. 133 mm will be the 133.5 mm, and the center of the disc that is will be 63.5 mm. That will be the measuring point of the wheel dia. Main wheel it is taking average rotation. For 10 times rotation, they are taking the average value. When the case of manual measurement is just a single unit only. Then I told you when wheel profile, wheel profile limit. Like that, wheel dia limit is there, safety concern, and like that, profile also limit will be there. New wheel, turned wheel, flange thickness will be 32 mm. It can wear up to, wear limit is permitted to 3 mm. 3 mm means flange thickness go up to, can reduce up to 29 mm. Root radius, that is only 37.5, but the limit is 6 mm, that is 31.5 mm. If it is reaching means either we have to, less dia means we have to make a condom. If intermediate dia means we have to give nominate it for wheel turning. For reprofiling, again we have to bring back to flange thickness 32 mm, root thickness 37.5 mm. That will be the safe running of the train. But wheel wear will be that life will reduce it. For that we are keeping intermediate profile. That I will tell you later on. Okay? That is a intermediate profile we are permitting. Otherwise wheel life will reduce that. Minimum it should survey the next schedule. And that only I am telling, sir, that WAP7 is supposed to serve next 3 months. But based on our experience, how much normally 3 months, how much wear will take place on the next 3 months? From that we have to calculate, not specified. Intermediate profile we can run the locomotive. It should be within like this. Within. Zero means when means if it is turned or new. If once a turned wheel or new wheel we are receiving with a zero profile, even if it is reaching 1.5 we need not to go for wheel turning. We can give it for service. No, where is specified. These are the some earlier we have discussed about that wheel diameter limit and flange wear limit. Now it is going to lateral clearance. Lateral clearance. The axle box lateral movement is there in the between bogie and axle box pedestal will be there. Total movement is restricted in a particular value. The part of safety concern and wheel life also. For that only this table is given. Then inspection number also it is there. The detail I think it is not required for detail. You will be getting boring only. So anyway, limit wheel is there. For WAP for lateral clearance will be there. That is it will vary for end wheel, middle wheel it will vary. And longitudinal clearance is same only. Longitudinal clearance means in the train moving axis is there na in that moment. How much will be the gap we have to maintain between bogie, pedestal and the axle box? That is the longitudinal clearance. What will be the clearance we have to maintain between axle box lateral axle? These are the WP7 it is varying. W4 it is limit is there and the guideline also it is there. Here is for WH7 also. These are the C1, C2, C3 is the axle box pedestal clearance. One location, axle box. Here axle box will be there. Here one bogie pedestal will be there. Here this is the axle box one. C1, then C2 from here, then again C3, then C4 like that. It will be calculated. I think this may not. I will not help you. That also it will be boring only for you. Next we will go. Financial expenditure on wheel change in midlife. While considering the wear of the wheel. Here is the wheel wear management. The cost of the wheel. Disc. One wheel disc itself it will cost around 1,25,000. So per wheel set it will go to 2,50,000. If we are changing in midlife, it is supposed to serve in the full life. But if you are changing means this will be the first one. And cost of lifting for the wheel changing and labor charge, this and all average only for why it is required. Why that wheel wear management, what is the necessity of the wheel wear management? In that view only I am telling all these things. Otherwise it is not required for you. Okay. 35 around 20 manpower is consuming the 35,000 crane power cost for this that much KW is consuming and for that rupees 560 like that this much is the approximate 4 lakhs around 4 lakhs per ஒரு wheel change பண்ண that's it around for one single wheel service this much expenditure will take place. Here also loss of duty, local detention not yet considered, that Sudhir sir has to give. If per day how much it will be there? Per hour it will be 1,600 rupees na. ಇಲ್ಲ ಡಿಸ್ಕ್ ಕಾಸ್ಟ್ ಎಲ್ಲ ಬರುದು ಸರ್ ಡಿಸ್ಕ್ ಕಾಸ್ಟ್ ಬರುದು ಅದ ಮೇನ್ ಅವಂದು this one will just radiator wheels are one most of safety critical component of locomotive. Wheels are designed to have a failure free life up to the condemning life. It is supposed to design only designed like that, only in between something is happening. Wheels having good profiles and a dimension profile is limited to some particular value against wear and safety. While considering this a safety measure and life, but occasionally require to be replaced out of course during midlife, either due to excessive wear rate, due to excessive wear rate. That is one thing. Due to reliability related issues like gauge widening and breakage of rim. Rim, suppose if any disc breakage means further we cannot allow into service now. That is safety. Gauge widening is also. It may go and derail. There is a chance for derailment. That is lateral. Okay. Factors directly affecting wheel wear. These are the things. Sir has asked now. Once wheel profile become, flange wear become 3 mm. We have to nominate for wheel profiling, reprofiling, wheel profiling. On that wheel profiling, how they are becoming the 0 brought into the 0 profile, or 29 mm thick flange, how they can brought into the 32 mm by reducing the diameter. By reducing the diameter only, they are able to bring back the normal profile of the wheel. So, at the time of condemning profile, what they are doing, they are reducing and they are brought back the profile into 0 wear, or flange wear is flange thickness is 32 mm, or root thickness will be 37.5 mm. In that itself, dia reduction will be there. That is one of the factor for the directly affecting the wheel life of the this one. Then it is the second one, skidded wheel. Skidded wheel. Skidded wheel also we cannot permit on service. We have to bring back the normal profile. We have to, for that we have to either we have to change the wheel or we have to turn the wheel to its normal profile. In that time also that dia reduction will be there. That will directly affect the wheel life. Wheel wear when skidded wheel is the one of the main culprit. Wheel dia reduction. Sir, Sudhir sir, getting இல்லையா? அதான். If the wheel profile brought back to 0 from 6 mm root wear or 3 mm flange wear means, if we are without keeping intermediate profile, if we are brought back to 0 wear profile, root flange wear will be the minimum 1 mm for clearing 1 mm flange wear. It will take minimum 6 mm of dia reduction. So, clearing 3 mm flange wear, it will take 15 to 18 mm dia reduction. If you are hearing 0, once it become 3 mm wear or 29 mm flange thickness, if you are brought back to 0 or 32 mm profile, like that, how many times we can go? Like that only thing. Considering the effective wheel diameter of 76 mm, only 4 times we can do that wheel turning. But there is some aspects. Some aspects are there. The wheel life, some profile is not uniform. It will vary some location. That is the next slide I will give you. Okay. 4 times only reprofiling only possible where up to maximum. Flange wear is maximum 4.22 mm times only we can do tire turning. This is a skidded wheel. Next one is factory sufficient wheel wear is a cut mark on flange. Cut mark on flange. Where it is a cut mark? Normally it will happening whenever that while passing the train on crossover, a yard and all, some maintenance may not be there. So that track may not be maintained in good condition. On that time while crossover, that rail sharp point will come on hit on here. Once if noticed means further we cannot allow as it is, even during inspection or whatever, whenever it may be. So here also that profile we have to bring back. For that we have to nominate it for wheel training. So definitely director will be there. So many double. Here also in our wheel it also while movement we are getting like this. Some point here also LCD is having some issues like this. These are directly affecting the wheel life. Some scratch mark, wheel tire portion we are getting scratch mark like this. Roaring sound will come. Roaring sound, intermittent sound, some roaring sound will come. And later on it will aggregate. And it will become more and more means it like it will become as a skid, small skid. It will come sound and driver customer feedback may be there. That is skidded wheel like that. For that also we have to once inspection means notice means we have to give it for training. On this occasion direct will be there. It will affect the wheel life of the locomotive. Punch mark. Punch mark. Punch mark means suppose if it is rolling, disc or wheel is rolling on some foreign bodies. So many people will doing welding on rail itself in our, and they are keeping some nut bolts on rail. After completion of work, they are not taking back. But driver also at appointments also not carrying, they are running. And ultimately that impression will take some year only. Once if it is happening means we have to clear it. Otherwise from that point itself there is a chance for crack, stress point. Then another thing is wheel distance. The distance between the two. Why it is telling about the distance means that also giving issue. The case of the life wheel life. Normal distance between two disc will be two wheel will be 1596 plus or minus 0.5 mm while receiving new wheel set. And it service is up to it can minus tolerance is same only 1595.5 only. Where in the case of plus side there is a 3 mm tolerance it is there. It can go up to 1599 mm during service online, not in from shed. Okay. If it is going beyond that 1595.5, while measuring itself, if we are having 1595.5, which wheel set having 1050, we cannot offer it for service. We have to give it for pre-disking to lock hours. Then what they will do? They will do face turning. Here we don't have that facility, face turning. What this area they will do? We are having facility on turning on this area only. But lockers having this facility of turning on this area. By turning that face, they can increase the wheel distance. But on that time also, what will happen? Dia reduction will be there. That the thickness, here we are clearing this portion means flange thickness will reduce. So what will happen? Again we have to go for reprofiling on the periphery. So that time also again the reduction will be done. So minus tolerance also, if it is affecting, and plus tolerance also, it is also against safety. 50 tight will have. Right side illa. രണ്ട് സൈഡും ടേം ആണ്. ഇല്ല മൈനസ് ടോളറൻസ് കൊടുത്തിരിക്കുക. എപ്പോ വന്നാൽ ടൈറ്റ് ട്രാക്ക് വരില്ല, ടൈറ്റ് ട്രാക്ക്. மைனஸ் டோலரன்ஸ் கொடுத்துருக்கேங்க, அதுக்கெல்லாம் வரக்கூடாது. ப்ளஸ் டோலரன்ஸ்ல போகக்கூடாது. Plus tolerance is wheel widening, how when it will happen at the time of brake binding only, normally wheel widening will take place. Here is less, 1595 point, less than 5 means that is a shrinkage of the wheel. Where in the case of wheel widening, it should be more than 1599 mm. If it is more than 1599 mm, that wheel we can call it as a Loading. Widening when it will happen means if it is under brake binding during service, if it is worked with brake binding, what will happen? Overheating will take place here. Rim. Overheating will take place. That will conveying to disc. Disc is having this much thickness, this much thickness only, 22 much thickness only. Disc. In that, it will lose its elastic property and permanent set will take place. Permanent set will take place. Suppose if or MS or elastic or steel, if you are pulling and leaving means it will go again back. That is elastic property. Na? That property will lose here. That means loaded condition. Normally load will apply on this both end, and on that condition this area, this flange area will swing, and this will wide. So suppose if it is a 1596 on normal condition, while loaded condition it will be 1595 only, or 1595 or 1595.5 only. Loaded condition at the bottom portion. Where in the case of top it will be 1596.5 like that it will be there. Micron times widening will be there. Since it is both side, both end load is applied. So there will be minor bend on the micron terms bend in the axle also will be there, and that elastic property disc that itself will bend. Like the loaded unloaded condition like this it will be there. But loaded condition like this it will be there. It automatically on run it will come up. Then automatically the elastic property will work and top will become normal. And top when it will become bottom, that will swing. But if it is permanent set takes place, on that time it will not come. That normal position it will not come. That is for that. If permanent set means we cannot measure it on load. If any doubt means some measurement will be there. So it can have 1595.5 and 1595.5, 1595. If it is less than that, we have to offload. We have to offload the wheel by removing the loco body, or we have to keep it on the wheel lace, and particular wheel alone we have to offload, and that we have to rotate it, and then we have to measure at three location. But RDS is telling minimum of 3 locations. We have to take and average value we have to consider. Like that it is there. 120 degree. Skin the material. Steel on specification. So wheel shrink is the problem. Then wheel widening is problem. Then next is disc crack. Earlier we were using composite brake block, and at that time we got some crack here also, LCD also. And if it is working on for a long period with a brake bind condition, some crack will take place, and manufacturing defects. Some hole will be there, this as a prag hole. Earlier, some hole will be there, will disc. Nowadays we are doing MPT to detect the crack from generating from that area. Earlier, that manufacturing issues, some crack were developing. Okay. This and all further we are going to give it service as a safety concern. We have to go for replacement. That will directly affect the wheel life. Biased wear. Just read it. No, just same axle, left to right it is there now. In the any one axle, wheel setting is getting more wear. That is what is called bias wear. One side no problem, right side no problem, left side only wear is taking place, or RH is okay, LH only taking place. And normally both side uniform wear should be there. That is due to so many reasons are there. That is, but bias wire is the culprit. That is a one point which affects the wheel life. Okay. And another one is ஒரு தப்பல் மட்டும் செஞ்சு போற மாதிரி. Like that it is there. Okay. That is normally how it is happening. The PH WhatsApp and all actually while repair, if we are giving repairing for the wheel set, what they are doing without keeping centering of the axle, they are doing repair of any one of the disc. That means if MSU, motor suspension unit having some issues, need some overhauling and some repair means actually they need not to remove both discs. Only any one disc is they have to remove for take out this MSU bearing tube and all. But for safe easy purpose they will normally disturb only non-gear end. Non-gear end disc only they will disturb. Since gear it is there. Otherwise they have to go for gear removal also. So any one side only they will. So while refitting, if they are not able to keep on the old position or with respect to the correct center of the, they are not able to keep the with respect to center of the axle. On that term, that distance from the axle to this particular disturbed axle, that axle to that wheel face distance will vary. So that will give problem later on during service. While giving during service, that axis it cannot maintain. All the axle box, all the wheel set will be in the same axis longitudinally. That will vary. That itself will create more wear on the particular wheel. That is what is called a biased wheel. That is one of the reason. Another one is giving one. Bogie squareness. Same issue may be there in the bogie. Bogie pedestal at the time of manufacturing or some derailment or some accident like that. If it is that profile display, bogie pedestal, that the profile is disturbed or damaged or deviated means that also giving the same effect only. It will not allow to keep the same axis in all the wheel working. That on that time also what that particular where it is getting deviated, that particular wheel on will get more wear. And that also biased wear only. Some direction, some locomotive is working in a, suppose for example, some locomotives or multi is working in a particular for a 3 month, 4 month for a particular area only. Some Salem to power station Metu Dam. Salem to Metu Dam. It is working for the 6 months, particular MC alone means how it will. The curvature, this negotiating curvature will be same only. Like that Chennai, far down. That and all particular train, particular loco working for a long period means the particular wheel alone will get weighed. Particular that is all either even wheel set or odd wheel set will get weighed. Okay, run out. Measures adapted to limit the wheel wear. What is our aim? We have to reduce the wheel wear. Adopt most suitable profile for the optimum life. Here is this 1 mm flange where it is there, 2 mm flange where it is there, 3 mm flange where it is there, 6 mm root where it is there. In that which area, which limit, which 2.5 or 1.5, which one we have to select? In that by experience, we have to do study and in that we have to decide and how it is behaving that profile in various locomotives with respect to distance, that and all we have studied and from that we have to select one optimum, that a good profile for the better life of the wheel locomotive. That is the scale where the solno. Purida boradida. Okay. Then consistent monitoring of profile. Consistent monitoring of profile. Wheel profile. Continuously we have to monitor the profile. For that detail will come one by one. Then implement the tire turning limit, discard misbehavior and strict monitoring of tire reduction during wheel turning. These are the things and one by one it will come. The first one we will go to adapt most suitable profile. This is the most suitable profile we can tell. Here it is a wheel flange wear or root wear, whatever it may be. Here it is a distance traveled in kilometer, whatever distance traveled. I don't know kilometer, whatever. Normally, this behavior of the wheel flange profile, it is from 0 to up to 1 mm. It will reach suddenly. The distance traveled will be 1 mm, this much only. This that's ah, ah. This much distance, maybe kilometer or 10,000 like that, it may be there like this. Within that 1 mm profile it will come. It will vary loco to loco, but normal common the behavior of the wheel profile is like this only. Okay, then from 1.2, how it is behaving? See, for reaching at the flange wear of 2 mm or 1.5 mm, how long it is taking? See, there will not be sharp shooting. There will not be. From here to here, it will be almost stabilized condition. There will not be sudden raise. Okay? And after 2, 2 or 2.2, 2.5 like that, then again like this, it will perform like this only. Shoot up. This is a common behavior of the wheel profile. And it will vary, it will vary the type of profile, thick flange or wear after, and type of locomotive like that. Thick wear same da. Same da. On the kilometer running will be different. And what type of locomotive what you are using? We are using profile, thick, wear after profile. The pattern same. Almost same. Almost same. Same. Thick flange, sudden the distance travel will be less comparatively. Parallel வந்து கொஞ்சம் கூட இருக்கும். W7 is less speed only, maximum 70 kmph like that it will go. That for that we have to have a study. Minimum of 50, 10 or 20 to 25 locomotive with a different wheel dia range we have to analyze. And what will be the better profile with optimum life we have to consider and we have to take it. Okay? Consistent then I have told it is second is consistent monitoring. These are the things what we are doing in ELSCED. Consistent monitoring. Outside trip shed nowadays, earlier they were not doing the profile checking. But recently we got some issues with train working beyond the service 3 mm and above flange where it was working. From Ernakulam also we got one case. Around 3 mm flange where we have given service without accidentally it was given. So from that the headquarters has given instruction based on that every trip shed now they are outfitted trip shed they are measuring wheel profile on arrival of the locomotive and their feedback. Yes, they are giving feedback and according to our decision they are taking for the next action whether we have to make dead or we can move to wheel shed or we can call back to farm shed like that. That is another one. It's a consistent one. And special CC. Earlier special CC was not there, but on implementation of this thick flange only, we have started this special CC. Since we are not able to predict the profile, so it was jumping like anything. Within month, and by month itself, it is going to or reach sometimes once it has gone to 5.5 flange wear in between schedule. So because of that only, we implemented this special coaching, especially for passenger locomotive. Where in the case of WAP4, it is in once in 30 days. Where in the case of WAP7, once in 45 days. That also we are monitoring. Close monitoring and the minor schedule. That also. That is a normal routine only. And tire training. Tire training also we are monitoring the profile. And how much we have to keep like that, after training. Wheelless, titanium means wheelless only. Here it is a titanium limit. Titanium limit from on what basis we have to decide. For that, these are the things we have to consider. Once loco came for wheel training, 1 mm plunger may be there, 1.5 is there, 2 may be there, 3 may be there. So how much they have to bring back? That for that deciding these are the factors. Based on most suitable profile, number one. Then based on present wheel dia. If 1092 wheel having 2.5 profile means it can bring back to 1 mm, nothing issues there. 6 mm or 7 mm, even 10 mm we can go for cutting. Total direction measurement. Where in the case of if one wheel set is giving for a local is giving for a 1030 wheel set, whether it can give it to 10 mm cutting? No. It has to be restricted to according to the percent diameter of the recommended. Or minimum dia reduction only we have to do. Otherwise, the overall procedure we have already we have to do again. Na? Then periodicity of special CC. Suppose WP7 and periodicity of special CC is once in 45 days. Once if you are permitting that having behavior of high wheel wear locomotive, it is jumping within schedule to schedule 1 mm jumping is there or 1.5 like it is there. If you are permitting 2 mm flange wear, it may go beyond the service within next 45 days. So like that. So what will be the periodicity of the special coaching? 45 days. If it will be served within safely served within next 45 days, we can give. Otherwise, we have to bring back it again. Like that for the case of WAP for within 30 days only. Within 30 days, it should not go beyond the service limit or safety. Now, commonly we are adopting WAP7. We are nominating wheel set locomotive with a flange wear of 2 mm for not for wheel training as a dia difference correction. In that minimum dia reduction only they will do 2 mm, 3 mm only. But only the same axle I have already told now. 2 mm only we have to keep same axle. Like that, if it is more, that is, they will bring back it again. And once it is training, they have to keep it in 0.5 only. Okay? W7 also. சொல்லியா நீ லேட்டா முன்னாடி வந்திருக்கணும். தனியா தர இன்னொன்னு next one is wheel wear management part of a discarded misbehaved wheel or bogie. Some one axle, if continuously it is misbehaving, means continuously wheel wear is more or biased wear is being happened in a particular wheel. Better completely training and better often giving for training and pairing for adjacent wheel. Apart from this, tire training will take place, direction will be with the culprit. And apart from that, adjacent wheel, we have to keep within 5 mm dia difference. If it is 8 mm, it is there. 1030, 1040 is there, no? Even we can keep up to 1035 mm. So unnecessarily we have to turn next 2 wheels 5 mm. So better if you are able to know that this is a culprit, it is not behaving, it is behaving badly and often it is giving problem, means better to remove. That's all. That is what is there written there. Same in the case of bogie also. Okay. Strict monitoring of in dia reduction during dia training. Minimize the dia reducing during wheel training dia difference. Now I just now told that 2 mm 1.5 flange and all there normally we are giving for wheel training for dia difference correction. For that What are the limits we have specified in the same axle, same bogie, same loco? That they have to keep. Apart from that, that much only they have to keep. No, that also maximum limit is there. Minimum is 2 mm. Same bogie. When maximum it can go to with a wheel dia 30 mm, 35 mm, they should not go up to 4 mm. They should not keep 2 mm dia difference. They can go up to 3.5 mm. So dia will be saved. Life will be saved. Like that. Like that, dia difference they have to do turning. Minimize the dia direction while pairing. Pairing with same only for adjacent wheel. Axle 3 is having issues with the wheel profile. That if if we are pairing with the axle 2 and 3, that also limit it will be there. 2 to 5 mm limit. That limit W7 we are having 5 mm the difference is permitted. W4 also the 5 mm dia difference it is there. Actually, if it is new wheels, they have to keep 0.51 dia difference. Same axle and 2 mm in same bogie. But where in the case of less than cases and all, they need not to go this is minimum limit. They can go up to maximum limit. Like that, they have wisely turned with respect to current diameter. Object of wheel wear management. ನಮ್ಮ ಇದಕ್ಕಾಗ the wheel life this and all wheel wear managing to achieve the optimum life of the wheel to avoid unscheduled lifting. General commonly to avoid wastage of manpower due to intermittent overhauling. Once again in between, if you want to really change the wheel set means we have to do overhauling, and also all work we have to be repeated to avoid detention of locomotive online and improve reliability of locomotive. This is all common only. At present, how much is the wheel life we are getting? Based on the dia reduction happened during the last wheel turning, last 10 wheel turning, 6 wheel turning. Average value we are taking. In a bogie. For the last 5 wheel turning, for a period of 1 year or 6 months or 7, 8 months, how much is the last per like that, and we are calculating WF for a period 2.6 mm for schedule to schedule it is happening. WH is 7. That is 30 days. 0.7 only. It is giving more than 9 years life. 9 years life it is there. That is in terms of month it is here. Here it is 29 to 30 mm. What is the periodicity of the WP for TOH? Huh? TOH in the periodicity at 18 months. 18 months. 1092. If you are providing 1092 wheel set, what will be the diameter after 18 months? 2.6 into 9 போடுங்க. 30 இல்ல 2.9 into 18. Huh? 46.8. Effective diameter. How much is the effective diameter? 1092 marks 10 16 76. 76 minus 42. 42. Well, if you are providing the same wheel set on the next day, whether we can predict it will last up to the. So in between automatically that repetition will take place. So what we will do? Only thing through the wheel wear management, we have to achieve the wheel life between 2 consecutive major overhauling. Then only otherwise no. Like this WH7 also you can see. 30 months 1.4 periodicity of minor schedule itself 3 months. 3 into 1.4 how much it will come? 4.2 mm. for 0.5. These are all ideal case only. These are all ideal case only. If it is happening, wheel skid, punch, like this, what will happen? Even though if it's ideal case also, you see 1.4 mm into 3 or what will be 27 months. For 27 months, how much it will be there? 27 into 1.4, how much it will be there? Yes, sir? Huh? Uh, uh, 30, 76 minus பண்ணா that is the ideal case only. Ideal case only. If in between any skid, scratch mark or punch mark like that, anything means what? It cannot run. Okay. These are the things is going on now. That is a profile adapted is a wear adapter. Thick flange, it will give more wear. Engi paranga. It flange is a 2.6 mm. Where in the case of WP7, it is 1.4 mm only. W7 it is 0.7 only. So it will work more than 9 years. Wear adapter. Okay, അടുത്ത slide പോകാം. Normally it will survive, but in between WP4, since it is working on wheel with a thick flange, we cannot predict. In between some bogie interchanging or something intermittent overhauling is required. Wheel changing is required. Now also more 4 locomotives it is there. WP7 some locomotive is there. WP4 some locomotives all are required. Mid-time changing is required. Is that okay? Wheel wear ஒன்றுத்தில்லமா இன்னும் இருக்கு, நிறைய ஸ்லைடு இருக்கு. இந்த 1 hour ஆகுது, ஏதாவது சொல்றேன் நான் நினைக்கணும் இல்லை. அட்லீஸ்ட் வீல் வேர் ஃபோக்கஸிங் இது பண்ணலாம். நெக்ஸ்ட் கிளாஸ் என்ன சொல்லுங்க? நெக்ஸ்ட் கிளாஸ் ஓகே, நெக்ஸ்ட் கிளாஸ் வச்சுக்கலாம். வீல் வேர் மேனேஜ்மெண்ட் ஃபோக்கஸிங் ஆன் இன்னும் சம் சொல்லிட்டா. ஓகே ஓகே. Line mark, if it's diagonally means that will not affect it that much. That pyrometer we have to, that for that also limit is there, maximum of 6 mm. Otherwise during negotiation that point that will misguide. Turning பண்ணணும். That also limit it is there. Maximum of 6 mm or within 5 to 6 mm we can allow. If it is more than that, we have to give it for turning. Otherwise, while crossover, there is a misguiding. Misguiding may come. Hey. Okay. Okay. I already told now. Actually, our aim is life between 2 consecutive matches scheduled. Next, to avoid wastage of manpower due to repetition of overhauling. In mid-time of the discarding on the turn, like that we have to do. To avoid additional locomotive, to avoid huge financial expenditure. Okay. Then there is a guideline from RDSO. Radius. These are the guidelines for the wheel wear management. There is an inspection bulletin from 2009 and the MS 250 is there for mechanical side removal of side stopper. Earlier W7 lock was provided with a 4 side stopper. So it was not able to negotiate it. It was giving some biased wear for that. Then the MS 49 longitudinal lighting. Earlier we were keeping here some point 0.6 to 0.4 like that and to something clearance, longitudinal clearance they have given some relaxation. Earlier it was less. And TC63, what it is telling? This is also for WSL longitudinal clearance, relaxation they are given, and that some guidelines are given for to avoid wheel skid and bias wear. Some guidelines they are given. As per TC83, wheel dia difference permissible in for WP7 revised. SMA 1 is a driving technique. This is the most important. SMA 1 driving technique and use of a proportionate brake to prevent wheel skid. VAF. VAF, then new. Along with while applying that formation brake, driver has to press BPF to avoid that proportional brake. Otherwise, wheel skid will take place. That force from the rear formation, it will go and hit on this, and if it is brake applied, loco is already in a brake applied condition, brake skid will take place. That will reduce our wheel life for clearing. Then releasing of handbrake. So many occasions without releasing handbrake, so many shunter and all they are doing working. That's also creating into the wheel skid. And emergency brake application in case of situation it can do. But for checking this brake, somebody is doing emergency application during service means that also will lead into the wheel skid. And releasing a brake in a rear locker during, this is the most crucial culprit. MU. While working with the MU, they are not ensured. They have to ensure the proper releasing of the brake in the rear loco. Some cases, occasionally, they are not, maybe the malfunctioning of the pneumatic circuit, some issues may be there, or there. Whatever it may be, do. Most of the cases, brake bending is coming and the brake widening is taking place. We are forced to replace the whole wheel set. The object of the wheel wear management, as per this bulletin, revise the wheel wear management is according to we have to revise up to we have to update and incorporate with better maintenance practice inspection to improve wheel wearability. Review wheel maintenance parameters. Brake block, that is also in that guideline that inspection bulletin some point, some important point they have procurement of manufacturer that brake block has to be secured and width of the brake block, that road trading should not be there. That is our CND's main is road trading, out trading. That then should not be there in the during alignment, and hardness of the brake block also it should be 250 to 250 BHN. If it is more, what will happen? Brake block will not wear, wheel only will wear, wheel only will wear. Okay. Then brake blocks are given in taper. 1 in 20 tapering we have told, and that it has to be matched. Otherwise also will problem will come. Alignment of brake anchor, verticality, that so many foreign bodies are hitting and derailment etc. will take place on that time also. At the time of inspection we have to see the proper alignment of the verticality we have to keep up. Otherwise it will go and ride on this root and flange of the wheel. That also create. It should be strictly ensured that brake blocks never touch the root. Okay. The tie bar. Nowadays tie bar. WP7, W7 we are maintaining with the tie bar, brake tie bar. That was the high speed working. If any foreign body cattle run over, it is getting damaged. Apart from the damage, that it will shrink. This due to heating force, it will shrink and it will pull both the brake block into the near to the wheel flange. So what will happen? Automatically will take on brake cylinder pressure is also okay. 1.8 has to be maintained. Excessive thermal loading. If the brake pressure is more means brake pressure due to repeated application, there is a chance for wheel widening. Dynamic. This one we have to ensure the dynamic or maximum optimum utilization of the dynamic brake. That also will save the wheel life. Ensure the designed brake power to maintain desired clearances. That we have to keep 10 mm gap from the brake block to wheel, like that. Some clearance it is that and all will be there. And spring grouping also, spring grouping. The sprung weight of the loco body is passing through this one only. On that time also, if any one coil spring is not grouped or not matched properly, will say one location on one wheel alone will be overloaded, offloaded. So automatically opposite side that effect will take place. Bias where issues will may come. Pins and bushes where also. My IOS must change than what we are telling now. That also otherwise will give problem to us. Breaking with excessive wear or play may lead into the brake bending, like that. It is guideline. This is not a guideline from the DSO through that inspection bulletin only. Lateral line, if it is lateral and longitudinal clearance is more, that also will affect the wheel life. Punch mark, here it is specific correctly. Punch mark on rim acts as a stress concentration point like notches. 2-3 cases, the punch mark itself led into the wheel crack. So we can't leave punch mark, we can't leave as it is. We have to clear it. And correct cause of the bias where we have to find out a brake block rubbing on with distant Lexus wheel lateral clearance, misalignment, axle box lateral clearance, bogie frame, pedestal lateral, lesser longitudinal.